Hello everyone, today I have a new gravity motor design. It's based on William Skinner's machine. Now I'll just show you how it works. So we have one weight here, spins. So the output is on the top here, and the input is on the bottom. So this setup is a little bit difficult for me to experiment with. So we're turning the bottom, okay, and then we want to put a load on the top. So if you build this yourself, you'll notice that whenever you put a load on the top, that's on this axle here, that it gets very easy to turn the bottom. So very simple. Now, let's move closer to the camera because everyone complains they can't hear me because I don't have a mic. I apologize, but I'm not getting a mic. So, this is very similar to Skinner's top weight, except it's upside down because we don't have the gimbal. Now let me show you. Now, I've tried different designs before. I've tried replicating his machine multiple times. Now, one important thing is that this lever here, so there's a collar on here with a set screw, so I could adjust this. This lever is very important. It will not work without this lever. So, gravity pulls down on this, and centrifugal force lifts up, okay? So, if you look at Skinner's machine, the top of his machine, it's hard to see, but it looks like this. You know, we can't know everything about the machine, but it looks like that. Now, I got too many weights on here, and this will fall over if I spin it too fast. So let me tell you where to go with this. So you can go and put in a gimbal, gimbal thing, if you want. Now, that lever has to be reversed if you have the gimbal. Let me draw you a picture. So with Skinner's, it's sort of set up like this, and then you have what I call is a top weight, and it's something like this, okay, and then the bottom weight. Now this one doesn't have what we would call the bottom weights, because I think it will work without it, and then that's 90 degrees behind it. Because obviously you don't want it too complicated. We have our top weight and our bottom weight. But what's hard to see is there's a lever here. So on his, it's directly above it, but on ours, it's the opposite. So if our weight is, it would be more like this, except, well, our design is rocks here, and then, so the weight is here, and then our lever is the opposite. But you can see with mine, I'm able to adjust it. Okay. With mine, I'm able to adjust it. I had to refocus the camera. and play around with it a little bit, which you may want to do that too. So this is very unstable, of course, very dangerous. It could fall over. So let's go over the Skinner's machine. So on Skinner's machine, he had about, let's say 900 pounds on the top, and then about 1,000 pounds on the bottom. So let's just say he had about 2,000 pounds of weight. Okay, and he was getting about 2 horsepower is estimated, so that's 1,500 watts. So he was getting 1 watt per 1.3 pounds. So that's really good. So he worked on it for 14 years. He had 4 or 5 different models. I think 4, 5, I think there was 5. And, I always thought it was a centrifugal force machine. Let's draw the rest of it. Let's not draw it. Not that good of an artist. Not an artist. Okay, what I was talking about. Okay, so 1 watt per 1.3 pounds. So that's really good. Really, really good. So that's our goal. So we're trying to do it with just one weight. You could try it with the top, and you could try all 4. But here's your expected power output. 1 watt per 1.3 pounds. Okay, so one thing that I did when I was creating this is that I was talking to someone, and he had a string, remember? Cotton thread running his machine with his motor. And I was talking to someone, and they said, no, you think it could be fake? And I said, no, it's not fake. There was people that said they even went to see his machine. It's on video. It's not fake. There's no way they could have faked it. So, how do you have a string, cotton thread, move 2,000 pounds of weight, turn a lathe, run a drill press, and a metal cutting saw? How do you do that? Well, there's only one way to do it. It's with that setup. It's with manipulation of the center. Okay? So I'm going to explain why this spins at the speed it does, why Skinner's turned at 60 RPM, etc. So there's different ways to manipulate the center. Like I tried oscillating, and the trouble with oscillating is that the bottom, or the input, in this case it's the bottom, could be the top. The input is oscillating, but the output is rotating, and they're not mechanically coupled. So without computers and, digital things, stepper motors and rotational position sensors, how do you keep it synchronized? It's impossible. So with this, I'm really happy because they have rotational input, and when you put a load on this, it's so easy you could use a string to run it. Now, if you overload it, of course, it's not going to work right. So here's another thing about how it works is, let's go back to our drawing board. With this type of machine, okay, even if you use a gimbal, right, like Skinner had. Okay, so that's supposed to be my gimbal. So he has the input here. So since the gimbal reverses the forces, you have to have a lever here with your input. And then if you don't have a gimbal, it has to be like here. But the weight has to hang down, okay? But the centrifugal force pushes it up. And so gravity pushes it down. So the speed that it runs at is when gravity, it just hovers around. Gravity is equal to centrifugal force. Okay? So the force of gravity is mg is equal to mv squared over r. Okay? So immediately we can cross out our m, and then we get 9.8 equals v squared over r. So let's say r is equal to 8 inches, 7.9 inches, which is 0.2 meters. 0.2 meters. So 0.2 times 9.8, like we multiply it by r, v squared. What's that? It's not supposed to be there. So we get 9.8 times 0.2 equals v squared. So v squared is equal to 1.96. So v equal to 1.4. I think my numbers are right. And that's in meters a second. Okay. So our nominal speed, where gravity and centrifugal force are the same, for radius, our average radius is 7.9 inches or 0.2 meters, is 1.4 meters a second, and we have a 0.2 meter radius, so we have 67 RPM. Okay, so if it was 0.1 meter, then we'd have v squared equals 0.98. Which is about 1, so v would be equal to 1. Okay, not the right way to do math, to draw all over everything. But you'd end up with, I forget, it's like 90 RPM. So if you have a smaller radius, you have less speed of your weight and a faster RPM. So Skinner's probably had about 8-inch average radius, so that's why he had about 60 RPM. Now, if you want to increase the speed, you could probably add a spring that would work the same as gravity. Let me grab a spring. You could have a spring. This is not even really a spring, but you see it's kind of constant tension, sort of, because it's really long. So you could have a spring that attaches to something stationary at the center, and that would probably work, but don't use a spring to start. Do it when you're an expert, or never do it. It's hard to get the right spring. So what happens is, I think what happens, I haven't studied this fully, but when this comes out, right, like this, it's spinning around. It's a bit heavy, so it's hard for me to manipulate. If this slows down, because the centrifugal force is mv squared over r, so if you lose a little bit of speed, you lose a lot of force, right? So rather than this pulling out, is almost floating. And that's the secret to most gravity motors, is when gravity and centrifugal force are about the same, you manipulate the center. You can move the weights around a little bit when the gravity and centrifugal force are canceling each other out pretty much. So since you use gravity, like I said, you're limited in speed, so you're limited in power output. If you can get 1 watt per 1.3 pounds, that's not bad at all, because a 12-inch disc of steel, 1 inch thick, is about 100 pounds. So like this steel here, I think that's like 8 inches. It's like 10 pounds. So steel's really heavy. Lead is like 40% heavier or something like that, but lead's expensive. So let me stop rambling and explain to you what I need to. So this is a CV axle. Now if you load this up, I think there's a snap ring or something holding that together, but that will pull right out. Okay? So that's not going to work with 1,000 pounds on here. So you're going to want to use a U-joint. That can take lots of force, lots of downward pressure. And here's one from, I think it's from a steering shaft on, Ford. It's pretty small though. Probably want to use the drive shaft one. And here I have a bearing. It's not the right way to use a bearing, but you can use a ball joint. And there's something else I should show you right there in the YouTube land. If you need to do a flexible coupling, you can have something, so these are fastened here, okay? So these can't shift, but these plates can flex. Like if this was thin, you can imagine pulling them apart, but they stay the same position relative to each other. So you might need a flexible coupling there at the bottom, and a ball joint, maybe an old ball joint that moves freely, because as you see this is fixed here all the way up to the top, right? Like I said, I don't know what's even holding this up, because this here there's no set screw in there. So that the distance, you see this is on an arc, so as this moves around sort of, as it wants to freely, that changes, and then this bearing moves around in here. Obviously you don't really want that, because it's metal on metal and it'll wear out, especially when it runs out of grease. Because you want to build something that's going to work, for 3 years and 7 months, until the rapture. So the other thing that I would do, and I'm planning on doing this, is that Skinner had 8 weights, so we had 4 sets of 2, which is crazy. Now I'm hoping this works really well and I don't have to go to having double weights. See, the issue, which I should have brought up earlier, the issue with the 2 weights is that it's really difficult to get everything moving smoothly. Everything just goes crazy. Somebody left a comment on one of my recent designs. It was about a year ago, but I have a mess going on, and who can argue? So Skinner's, what's crazy about it is that everything is just really spinning in a circle, or it looks like a circle, and everything is smooth, and you get lots of power, so it's beautiful. So that's my aim here, but to be simpler. So what you can do, so if you have 1,000 pounds of weight here, as this thing goes around, you're going to have 1,000 pounds on the frame, and like you can see, even this frame, it's only 100 ball steel. It starts flexing and waning, and you don't want that. So you want to do like Skinner has. You want a pair of weights, okay? I finally said it, I spit it out. You want a pair of weights. So you want one here, and you want to chain them together, or you could use a bunch of gears, but who uses gears in this day and age? So you want them 180 degrees apart. So there's lots of force between them, but they're not, trying to rip the frame apart and the bolts out of your concrete foundation, etc., etc., etc. So that's the simplest design that I've come up with, and I think it might actually work. Everyone should build this, try it out, but be careful, because don't do something like this. It'll fall on you, and that's not good. So yeah, and also, like, this is 100 wall steel. That's 100,000, so that's less than an eighth. I think this might be an eighth, but thicker steel is like at least 4 times better. So you want to use as heavy a steel as you can get. It's just day and night. Light steel is just flexible, and it's garbage. So that's pretty much it. Free energy machine you can build out of scrap parts. Something else I wanted to show you. For an electric motor, of course, you want to use a DC motor. Okay? So that's a treadmill motor. Really good motor you can get for, free, usually. If it'll focus. Come on. There we go. And you can take the flywheel off this. That'll just wind off. There's a shaft on the back. This one, I stepped on it and I broke the brush holders. But anyway, really good motor. Lasts forever. Here's another motor, 24 volt DC, 100 watt, be a good drive motor. These motors are kind of expensive. From Amazon, everything's so expensive now. And this is a Ford alternator. So the threads on it are M6 1.5. Now the pulleys that I bought are junk. You'd be better off making your own V-belt pulley. But I was reading up on the efficiency, and they sound like they're only 50% efficient. So not that great to start with for your generator. Okay. And the other thing I should mention, which I mentioned in previous videos, is that if you couple the output to the input, this type of machine will not work. So don't do it. Just put a generator, a battery. Try to make everything DC the same voltage. AC, people thought it was great for a lot of years, but in a lot of cases, AC is not so great. By the time you get an inverter, 2,000 watts, you start losing a lot of efficiencies. So, Skinner didn't have any kind of generator on his, but obviously he was probably trying to, avoid calling it a free energy machine with, clever use of wording. So hopefully that clears it up. So if nothing else from this long video, apologize, talk slow, is that you got to have this lever, okay? If I just hook this into this shaft, the machine will not work right. okay? So whichever way you set it up. So on Skinner's, this is the very top. There's gears here. There's something that looks like this. There's some other things that look like ball joints, but I'll just leave them out of this video. Okay. And then you have a gimbal here, right? Okay, so his lever, like I said, it's reversed. It's the other way because it has a gimbal. So that reverses the centrifugal force. Okay. It just puts it 180 degrees, no big deal. Okay, and then with Skinner's, since we're upside down, this here, right, because we have a gimbal here, instead of a fixed axle, this is floating, and then you have remember we're still upside down, you have the bottom weights, so like that. But this whole, free floating, moving around type thing, it worked good for Skinner. 1 watt per 1.3 pounds of weights. It worked really good, but the objective with this one is, let's build something, see how much power we can get out of it without all that mess, without having 8 weights, because even if you can get free energy, if your machine wears out in, a couple of days, well, you might as well have gone with solar panels or, something else, geothermal. So that's it. Let me know what you think in the comments. Let me know what you're working on. Thank you for watching. Goodbye.